Hello everybody. In this video we are going to study about subtractors. So there are two types of subtractor basically over here. There is first one is half subtractor, second one is full subtractor. So in half subtractor we also called as 2-bit subtractor, and for full subtractor also we called as 3-bit subtractor. Okay, so bit refers to binary bits, right? So already we have discussed how to understand 2-bit and 3-bit and how to get the value. I mean to say range from 0 to 3 or 0 to 7 in the earlier videos in full adder and half adder. You can refer from that. Okay, so directly I'm starting with the truth table. So designing of half subtractor, I have taken the truth table directly, two variables a and b. So when I subtract a and b, I'll be getting difference and borrow. So this bo is a thing, but to get it different from this b, I have taken bo over here. So this is called borrow, and this is called the variable b, right? So combinations obviously will be, because 2 bit, so combination will be from 0 to 3. So 0 0 0 1 1 0 1 1 I have taken. Now when I subtract this, 0 minus 0 is 0, borrow is also 0. 0 minus 1 is not possible, so I need to borrow 1. So I'm taking borrow 1 over here, which is making this 0 as 10. 10 minus 1 is 1. Okay. Now coming to the next one, 1 0. So 1 minus 0 is, difference is 1, borrow is 0. 1 minus 1 is 0 and 0. Now I have the truth table with me. Now I need to design the circuit. For that I need equation. For that I'm going for K-map. So K-map for whom? For D and for this BO. Okay, that is borrow. So D depends upon A and B, and BO also depends on A and B. So I need two variable K-map. So I have designed two variable K-map over here, that is for D and for borrow. Okay, so as per this truth table, from here I have two ones over here, that is 0 and 1. When A and B is 0 and 1, I'm getting 1 over here, so I have placed 1. 0 and 1 is 1, 1 and 0 is 1. You can see from the truth table. Okay, I placed it. I'm finding these two are individual. There is no question of pair or something higher versions, so two individuals are there. And from the half adder we have seen that this will come in an A XOR B pattern. So because A bar B and A B bar. Okay, so if I see this one, I'm getting A XOR B, right? Now coming to this one, what I'm getting is that a single one I'm getting, because you can see under B0 I have a single one over here, that is 0 1. I'm getting 1 because I'm borrowing 1 over here, because 10 minus 1 is 1, so I'm getting 1 over here. So that one I have taken over here. There is A bar and B, so A bar B I have taken for borrow. Okay, now I got the two equation for difference and borrow. Depending on this two equation, I'm designing the circuit over here. So D is given by A XOR B, so XOR gate I have used over here, and borrow is given by A bar B, so I have taken NOT gate over here connected, and an AND gate to get B out. Okay, or borrow, right? Now moving forward to a full subtractor. So over here design a full subtractor I have taken. So you know by this time full subtractor means 3 bits. So starting with 0 0 0 till 1 1 1 I have taken, and the values are A B C are the variables over here. And when I subtract this, I'll be getting a difference D and a borrow BO. Okay, I have taken. So now see over here, 0 minus 0 is 0, minus 0 is 0, so difference 0, borrow 0. 0 minus 0 is 0, 0 minus 1 is not possible, so I have taken a borrow 1, so it becomes 10, 10 minus 1 is 1, so I got 1 over here. In a similar way, the third one, you can see 0 minus 1 is not possible, so I need to take a borrow, so borrow is 1 over here. Okay, now this becomes 10, 10 minus 1 is 1, and 1 minus 0 is 1, so two ones I'm getting, one for borrow, one for difference over here, right? Now coming over here, again I have to take a borrow over here, so 10, 10 minus 1 is 1, so you can see borrow I have taken 1, so 10 minus 1 is 1, 1 minus 1 is 0, so I got 0 over here. This 1 minus 0 is 1, 1 minus 0 is 1, so 1, borrow is 0. 1 minus 0 is 1, 1 minus 1 is 0, so this is 0, this is 0. Now 1 and 1, so it will be 0 obviously, and this is 0, so it will be 0, so 0 0 I have taken. 1 minus 1 is 0. Now 0 minus 1 is not possible, right? So I have taken borrow 1 over here, so this becomes 10. Now 10 minus 1 is 1, so this is my truth table. Now placing the values of truth table in the Carnot map, and 3 variable Carnot map. Why? Because D depends upon 3 variable, that is A B C, and B0 also depends on 3 variable A B C. So I have taken 3 variable K-map over here, and I place the data from this truth table over here. You can see all the ones are individual ones. Let it be this one or this one or this one, all are individual ones. And we have seen the same structure in full adder. So the equations coming over here is A XOR B XOR C. You can put down the different mean terms, then you can solve it out. You will end up with these equations only. Okay, so directly I have written A XOR B XOR C. Now coming to the borrow part, so all the ones I placed over here. So I'm getting the 3 pairs, first pair, second pair, and third pair. So accordingly I have taken out the equation from here. The first one A bar and C. For the second one you can see is A bar and B, and this one is BC. I've got this equation. So basing on this two equation, A XOR B XOR C and A bar C plus A bar B plus BC, I have designed the circuit over here, which is nothing but the circuit for the full subtractor. ABC I have taken, 2 XOR gate I have taken, okay, and you can see for A bar I have taken NOT gate, and accordingly I have designed the circuit, okay. Now there is an alternative approach, just like in full adder, here full subtractor also there is an alternative approach over here I have shown you, okay, where I can design the same circuit using two half subtractor. Inside this box, what is there? This circuit is there, this circuit is there inside this box, okay. So you can see from the truth table, if I take, okay, so for D I will get the same equation, A XOR B XOR C, so I have kept that one as same. But B0, if I see 1 2 3 and 4 ones are there, so accordingly I have taken the values over here, and from this mean terms, okay, what I have done is that I have taken A bar B bar, okay, this A bar B bar, okay, and last one AB common, and C I have taken it out. So this is nothing but A XNOR B, this A XNOR B, so I can write A XOR B whole complement, that only I have written over here, and from middle two terms I have taken A bar B common, okay, A bar B common, and C bar C plus C bar, okay, from this two I have taken, so this becomes 1. So I'm getting final equation as A XOR B whole complement C plus A bar B, okay. Now I have designed this D and B0 equation with this circuit. You can see here I'll be getting what, two half subtractor I have taken to design the full subtractor over here. So here I'll be getting A XOR B, I'll be getting over here, right, but C will be what, because you can see a NOT gate over here, NOT gate, okay. So here I'll be getting, at this particular point I'll be getting the data that over here is A bar B I'll be getting over here, okay. Now this is coming in this way, okay, this first line is coming in this way and getting over here, that is A XOR B is coming, so C is getting XOR, so D is nothing but A XOR B XOR C. But what will carry? A XOR B complement will come, because this part will again got a NOT gate over here, right. So I'll be getting what, A XOR B complement, okay, into C, right. So over here I'll be getting, at this point I'll be getting what, at this point I'll be getting what, A XOR B whole complement into C, right, and from above I'm getting A bar B plus A bar B. So this is nothing but the equation for B borrow, okay. So this is how I design the alternate approach, where we are getting full subtractor using two half subtractor, okay. So I hope the concept is clear to everybody. Thank you for watching.